the perpendicular bisector of a line segment and its connect with circles. So here is a circle having two of its chords drawn and the center marked O. So let us see the perpendicular bisector of this chord by paper folding technique. So this fold is now the perpendicular bisector of the chord. We can observe here it passes through the center of the circle. Similarly, the perpendicular bisector of this chord, which is this crease now, is also passing through the center of the circle. So it clearly indicates I am drawing the perpendicular bisector now. It is clearly indicating that center is the point of intersection of all the perpendicular bisectors of different chords in a circle. So what is a perpendicular bisector? It is a perpendicular as well as a bisector. So we can observe here 12 centimeter chord is having its midpoint at 6. So the bisector, perpendicular bisector passes through the midpoint and it is also making a 90-degree angle. So we can observe the bisector of this 10 centimeter chord passes through the midpoint, which is at 5. The midpoint is at 5 and it is also the perpendicular to the chord. Observe the 90-degree angle which is made by the bisector at the midpoint. Similarly here. So a bisector refers to the line segment which is axis of symmetry for a line, for the given line segment, and bi refers to two, sect refers to sections or parts. So the bisector will divide the given line segment into two equal and congruent parts. So let us now draw the perpendicular bisector for a line segment and let us check what is special about it by procedure. So I have drawn 8 centimeter line segment. Let me name this as AB. To draw the bisector, I am taking more than half of AB and drawing two congruent circles with this more than half of AB as the radius. Two congruent circles having centers A and B. Two congruent circles. So one circle is here. And another circle is with the same radius, more than half of it. With A as center. You may be wondering why two circles are drawn for bisecting a line segment. What is its relevance? Let me come to that point later. So now I will join the point of intersection, the 2 points of the intersection of the circles, let me join it. And I will name this as Mn. So Mn happens to be the perpendicular bisector of the line segment AB 8 centimeter. So we can see here exactly at the midpoint 4 centimeter, the midpoint, we can see the perpendicular bisector Mn passes through, and obviously it makes 90-degree angle. So what is so special about this taking more than half of AB? What happens if in case I take exactly half of AB? Then obviously the midpoint is already known to us. But here we are finding the midpoint and then drawing the perpendicular at the midpoint. That should be the process. So that is why we are taking now more than half, so that two circles intersect. When we draw two circles having A and B as centers, two congruent circles, they intersect at M and N. Now, what is this Mn with reference to this circle? It is a chord, right? So Mn is a chord for each of the circle. So I can call it common chord. Mn is the common chord for the two circles, and AB happens to be the bisector of Mn as well. It is not only Mn but the bisector of AB, but AB is also the bisector of Mn. How do we understand this? The previous illustration that the bisector of any chord passes through the center helps me to connect to this idea. So bisector of this chord Mn passes through the center of first circle, as well as the bisector of Mn passes through the center of the other circle, because it is common chord. So now we will understand why this more than half. So let me draw this. Triangle AMB. So triangle AMB is isosceles. Can we have the reason why? Because AM is equal to MB, which is R, the radius of the two congruent circles. So we know that AM plus MB is greater than AB by triangle inequality property. So AM is R plus R is greater than AB. This indicates 2R is greater than AB. So R is greater than AB by 2. So that is the reason we are taking the radius more than half of AB. And hence we are sure to get the two circles intersecting in such a way that the perpendicular bisector Mn becomes the common chord. So this is the concept behind the perpendicular bisector and the circles, two congruent circles. So in case R exactly becomes the midpoint of the half of AB instead of more than half of AB. If half of AB is taken, then the circles won't intersect. They will be just touching. The two circles will be just touching at the midpoint, and we won't be getting the perpendicular bisector. There won't be any common chord also. So this beautiful concept helps us understand many more properties of circles. So one of the property, as we already learnt, that the bisector of a chord passes through the center of the circle, and any perpendicular drawn from the center to any of the chord will bisect, and hence these two are equal. So if I name this as O, MO is equal to NO. So that is one of the property, that any bisector will be perpendicular and the converse. Any perpendicular will be the bisector. And in case I join this whatever quadrilateral obtained is a rhombus. So we can get many more properties of rhombus here. The line segment taken AB and the perpendicular bisector, they both become the diagonals of the rhombus, and the AM, BM, BN and AN, they become the equal sides because they are the radii of the two circles. And we can learn something more about the properties of circles in the same construction. We need to explore. We can understand one more concept here. Given 2 points A and B, the minimum radius of a circle that can pass through A and B both is AB by 2. So here is the construction which we had just learnt now. So AB is the given line segment and MN is its bisector, and we had drawn here two congruent circles in the process. Now consider AB. What is this idea? It is telling us that I am given 2 points A and B, and I have to draw a circle which passes through both A and B. So if I try to cover that, both A and B, then obviously the radius which I have to take is half of AB. So you can observe here, half of AB is AO, and we can cover both A and B if I choose half of AB as radius. So the circle is obtained in this manner. Let us see what happens if it is less than half of AB. It will not be covering both the points A and B. So if I try to cover A, then B will not be actually covered. Or if I cover B, A will be missed. Actually, more than half is okay. So this can be understood. Now R is more than half of AB. So if I can cover taking this R as the radius, then I can draw covering from this point. I can cover both A and B. See here, another circle can be drawn covering both A and B. See? So this bigger circle now, having R as radius, is having AB as chord. AB is one of the chord now. But obviously not the diameter. Previously we drew with the half of AB, and that AB became the diameter, and that was at least half of the line segment given, or half of the distance given. But now more than half is also okay, as this radius is more than half. I can take more than half of AB and still draw a circle covering both A and B. So A and B are points on this bigger circle also. But obviously it's a chord now. AB is just a chord, not the diameter for this circle. For this bigger circle, AB is just a chord, whereas the first circle we drew with half of AB as radius, it is AB became the diameter. So obviously less than half of AB is not going to allow us to have A and B both simultaneously on the circle. Let us see, if instead of more than half, if I take exactly the same length as the given line segment for drawing the two circles, and that is taken as the radius, what happens? So AB is now, I have taken a 5 centimeter line segment. So let me take the length AB itself as the radius, and I am drawing two circles. One from B as center I have drawn already. Another from A as center I am drawing. Wow, the two circles, they are passing through each other's centers. So we can see here, with the A as center, if I draw a circle, that circle will pass through B. And with B as center, if I draw the circle, it will pass through A. So, can we see one equilateral triangle here? So, there is equilateral triangle. If I join the two intersecting points and name them as MN. MN is the perpendicular bisector for AB, as we already learnt. So, if I join this MB and MA, how is it equilateral? Because AB is same as MA, because we have not changed into more than half. Instead, we have taken it as equal to AB. So, AB and MA and MB are equal. So, all the three happen to be equal. So, we can mark this angle 60 and this also 60 degree and this also 60 degree. So let me create the same rhombus like how we have done before. So this is another 60, and this is 60. There is another important property of circles here. This angle, which is reflex angle created at the center of the circle, is 240 degree. It is 360 minus 120. So it is 240 degree. And this angle is 120. This angle is 120. Total angle MAN is 120. It is one of the important property called central angle theorem, where this arc MN or chord MN creates an angle at the center of the circle, the reflex angle, that is 240, and in the other side, other part of the circle, it is creating half of the 240 degree here. So that is one of the property. It will be illustrated when we draw circumcircle also. But here we can observe many more properties of this specific rhombus as well as circles. So actually any angle drawn here, probably here I can draw anywhere. So this angle will be 60 degree because this is 120. So it is also the central angle theorem. MBN is 120. So if I name this as MYN is 60. So it is also central angle theorem. At the center, it is this chord is creating angle 120, and at the any other part of the circle it is creating 60. So it's nice idea to explore the concepts using two concepts which are interconnected in constructions. You can observe this 60 degree angle by measurement 60. And this is 120. At the center.